Hi guys, we're back, and today we're going to look at curve analysis recap, and we're going to be talking about looking at the graph of the derivative and seeing what we can say about the original function. So we call this a graphical analysis. Pictured to the right is the graph of f prime of x. Use the graph to answer questions 7 through 13. So I'm looking at my function here. I want to remind myself, this is the graph of the derivative. So if I look at my questions, I'm going to try to figure out where I have a max, a min, where my function is increasing, and points of inflection. So I know I'm going to have to deal with the first derivative for the first three parts and the second derivative for the last part of the question. So I'm going to make myself two number lines. This is going to be my first derivative, and I'm going to make a number line for the second derivative. I'm going to put all my information on first, and then I'll go back and answer the questions. Okay, so when I'm looking at the graph of the derivative, if I want to find out the critical values to put on the number line, I'm going to look to see where the first derivative, or f prime, is equal to 0. These are going to be my x-intercepts, because I'm looking at the graph itself. So I'm going to have at 1 and at 4. That's where the derivative is 0. So those are the numbers that go on my number line. And now to figure out whether or not the derivative is positive or negative, now remember, I don't have a function to plug into, so I'm going to look at the actual graph itself. When the graph is below the x-axis, it's negative. When the graph is above the x-axis, it's positive. So when x is less than 1, the derivative is negative. When x is in between 1 and 4, the derivative is negative. And when x is larger than 4, the derivative is positive. Okay, so this tells me my function is decreasing, decreasing, increasing. So let's go back and see if we can answer questions 7, 8, and 9. What are the values where x has a relative maximum? Well, the maximum is going to occur when f prime is 0. And on the number line, I go from a positive to a negative. That does not happen. And I'm just going to my reasoning is here because f prime never goes from positive to negative. I'm not going to make you explain things on the test, so don't really worry about it. It's basically, what are you looking for? That's what you want to know at this point in time. What are the values of x where f of x has a relative min? Okay, so now a minimum value occurs when f prime is 0 and the signs change from negative to positive, right? My function goes from decreasing to increasing. So I'm going to have a minimum value when x is 4. On what intervals is the graph of f of x increasing? And what am I going to do there? I'm going to look for where f prime is greater than 0. So I'm going to look for the intervals where it's positive. And that's going to be when x is greater than 4, or we're pretty much used to writing it in interval notation like that. Now let's look at this last piece here. At what values of x does the graph of f of x have a point of inflection? So now we want to analyze the second derivative. Okay, so we're going to go back up to our graph. The second derivative, how am I going to find the numbers to put on the number line? Well, f double prime equal to 0 is going to be wherever the slope of the tangent is 0, or where I have horizontal tangents. So if I look at my picture, that's going to occur when x is 1 and when x is 3. Now I have to figure out how to put the signs. Remember, the second derivative is the derivative of the first derivative. In other words, we look at slope of the tangent lines. So when the slope is positive, right, here slope is negative, and in this interval the slope is positive again. We can also think about it like f prime is increasing F prime is decreasing, increasing. That's another way we could get our signs. So now if we could ask you more questions like where's the graph concave up or concave down? So I could ask you to describe intervals. That's how you would go about doing that. But this question is just focusing on the point of inflections. So for a point of inflection, we want to look to see where the derivative is 0 and it changes sign. It doesn't matter which direction sign changes in, as long as it changes signs. So I have a point of inflection at x equals 1 and another point of inflection when x equals 3. Okay, so that's just a little review from before break. Now let's just take a look at a couple of multiple choice type questions, okay, so you don't get overwhelmed if you see something like this on your test. The graph picture to the right is the graph of f prime of x. This is the derivative of a function. Which of the following statements is or are true? Okay, so if I look through my increasing, min, okay, I'm going to be analyzing the first derivative itself. Concave up, I'm going to need to look at the second derivative. So once again, I might want to make myself some number lines. Okay, so if I'm going to make a number line for the first derivative, I'm going to look, how do I get the critical values? It's going to be where f prime is 0. So that occurs at -5, -2, and 2. How do I get the pluses and minuses? Above and below the x-axis. So when x is less than -5, the graph of the derivative is below, so we put a negative. Between -5 and -2, the graph of the derivative is above. Between -2 and 2, the graph of the derivative is above. And then we go back down below. So f of x is increasing on the interval -5 to 2. Yeah, that's a true statement. F of x has a relative min when x equals -5. Well, a min is going to mean I go from negative to positive. That's a true statement. F of x is concave up. We're going to need to look at the second derivative. How do I get the numbers to put on the number line? They're my horizontal tangents. -4, -2, and 1. How do I get the signs? They're my slopes. Positive, negative, positive, negative. Concave up. I'm going to look for my positive section. So this is saying it's positive on -4 to -2. No. 1, 2, no. So that rules out that choice. So here, the only obvious answer is options 1 and 2 only. Another type of question, and again, now these are just, you have to kind of think a little bit and connect all of your information together. The function f has a property that f of x, f prime of x, and f double prime of x are negative. So what does that mean? F of x is less than 0. F prime of x is less than 0. F double prime of x is less than 0. So my function, or f of x, is going to be below the x-axis, decreasing, and concave down. Oops, double prime. So if you look at your choices here, this is concave down, but this function is increasing. Below the x-axis, decreasing, and concave down. There's your obvious answer. Let's just make sure nothing else works. This is increasing, this is above, and this function goes from concave down to concave up, so that one's out too. Okay, so I just wanted to give you a little bit of practice, seeing graphs again and seeing what to do in a multiple choice situation. And good luck with everything. Hope to see you soon.